Hello YouTube, Bill Griffith back again. In my previous video where I showed IBM Cloud Pak for Business Automation installed on IBM Public Cloud, I used the classic infrastructure, and I also tied it to a single availability zone, meaning a single data center. And I did that because the storage that I needed was NFS, which is tied to an availability zone, and that was simpler to use. However, if that data center went out, say Dallas 10 were to go down because the whole power grid went out, or a whole flood or tornado or something of that nature, sort of a somewhat of a disaster, then my application would go down. And so to resolve this, most public cloud providers have this concept of a multi-zone region. Here's a video I did about that. And what you have is you actually have three data centers. In this case, Dallas 10, Dallas 12, Dallas 13. Those are 10, 15 miles apart, and I can replicate my applications across those availability zones. So in this video, I'll show how to do that using the virtual private cloud network, and then as well as the multi-zone region data center. Effectively, what I'm trying to get to is this high availability for Cloud Pak for Business Automation. And you see down here, so instead of the storage being tied to a single availability zone like NFS, then I can replicate the data across, and it's using OpenShift Container Storage, which is now OpenShift Data Foundation, and it replicates the data synchronously. It's Ceph under the covers for open source folks. And then if the whole Dallas 10 data center goes away or has a disaster, then my application runs in the other fault zones, availability zones. And so the data is synchronized synchronously, or replicated synchronously, and this gives me a recovery time objective of 0 seconds because it's synchronous writes, as well as, since it's an active cluster, then I get recovery point objective of 0 downtimes, meaning that if there's an outage, immediately my applications are always on and available. And so that architecture slide is credits to Kevin and Dion. You can find this in high availability disaster recovery search on IBM support, but really good deck on that. So I'm going to show how to get that set up. So let's get started. Okay, so I pull up the IBM Cloud catalog and go search on OpenShift and find ROCs, Red Hat OpenShift Kubernetes Service. And so it is a custom cluster. I want a VPC, so I can create a VPC. And I'll just call this in North America. Let's put it in, let's create this one in Washington, D.C., since I already have one in Dallas. And let's call this WDC VPC demo. And I don't need that. Leave the defaults here and then say create. So I also need a object storage, and I am going to choose OpenShift for 11 to make sure I have an OpenShift that is supported. Okay, so I'm going to search on IBM Cloud Pak for Business Automation System Requirements, so I can get the hardware specs and the supported OpenShift versions. So this is 21. I want 2202. You see it's the system requirements. And you see here some details on the specs minimum. This is for all the capacity, all the capabilities, but in here also is the detailed system links, and then this will tell me what versions are supported for OpenShift. So I drill into my 2202, and you'll see over here in containers, this is supported on 411 and 412, so I'm going to put it on 411. Okay, I'm going to use my Cloud Pak entitlement. I'm going to leave the defaults here, Washington, D.C. 1, 2, and 3. So let's change this to, I'm going to make these 16 by 64. The Cloud Pak for Business Automation has a lot of memory. The pods have a lot of memory requirements, and so this will make it easier to get things scheduled and have enough resources. So I'm just going to reduce that down to 2 workers per zone, and zone is availability zone. So Dow 12, Dow 13, whatever they hear, or in this case, Washington, D.C. 1, 2, and 3. They'll have 2 different virtual machines in each data center, and then total of 6 across the 2. And so I'm going to name it here. So I'm going to name it CP for BA DFW demo. I can leave on my tracking and logging all of your SRE types of details. And I'll leave private and public endpoints, and then I will do create. And that'll take 30 minutes to an hour or so to spin up. You see my worker nodes are spread across 3 data centers, and so it's trying to install, and I want to wait to come back until it says ingress is ready. Now, while I'm doing this, it also is helpful to go set the public gateways for my VPC so that the nodes can talk to externally and get everything working. So let me go do that while I'm here in my VPC. I'm going to do my VPCs, and that new one that I just created is right here. So I'm going to drill into this. You see there's no public gateways for the subnet. So I'm going to go into each of these and turn on a public gateway. That's going to add an external IP address, which I have done there. That's one of them. Go back to my other. You see it turned it on there. I don't know if I can do it here. No, I can't. So then I go to the other one, attach it there. There is a cost associated with that IP address, just like all the other public clouds as well. It's nominal cost, but be aware of that. And so now my VPC has public IP addresses. Okay, so I am back at my public cloud. I'm going to go into my resource list, and you see here in my containers, of course I misnamed that. It's the DFW demo in Washington, D.C., but let's go into it anyway. And you see my ingress is healthy. That's a good sign. You can actually pull up the web console. That's another decent test to see that you got connectivity. And so there's my console. I can look at my storage classes. Just show these because you'll see that I'm going to install the OpenShift Data Foundation, and that will be different. It'll add a couple storage classes here. If you go to the compute, you see my nodes. Here are my 6 worker nodes. Okay, so now back over here, the IBM product management team has added this nice OpenShift Data Foundation. Click the link here for the docs, tell you a little bit about it. Here's another diagram sort of showing what's going on there. But let's go back here and let's install it. Okay, so I will use advanced. If I look over here in the docs, I scroll down, you can see the pros and cons of what you get between. And so advanced gives me the regional DR with replication, as well as stretched clusters, etc. So I'm going to go with that one. And back over here, you'll see that we want a Metro storage class has a volume binding of wait for first consumer. That setting docs don't describe a lot of it right here, but if you go over into the Kubernetes docs, they'll talk about that a little bit better. But basically what that's saying is that don't provision the storage until the pod is provisioned, and then it will allocate storage in the same data center area as the pod, so access will be available there. In an MZR, you could have a pod running in DAO 10 and then the storage in DAO 13. That could be problematic. It may not have access to that DAO 13, so even though it's all part of the same stretched cluster. So that's why that is important. You can set that setting yourself, or you can just choose a metro. In fact, if I go in here to my console, I'll show you the storage class and show you where that setting is set. If I go to my storage classes here, you'll see all of these with metro. And if you look at the YAML, you'll see down here they are all wait for first customer. If you go over and say the default, which is not metro in the title here, you'll see it says immediate, and this would be problematic in a MZR. It's fine in a single availability zone, but not so much in your MZR. So IBM by default chooses this one for you, and you see it right here. Okay, so let's go back and leave that as our backing store. And I choose install, so metro, and I'm going to bump this up to 500. You see it's actually 1500 because it's got 3 replicas of that data. You can in fact increase that if you want it, but that gives me redundancy, duplication of that data across all of my availability zones. So then I will, did I do install advanced? Yep. So I'm going to install it. And so that'll take 10-15 minutes or so. And okay, so about 10 minutes later, you see that OpenShift Foundation is installed and normal. And I can go over to my OpenShift console, which in here is just click this web console, go back over here, go into my storage. You'll see there's this data foundation layer. It shows me the status, the health, what's going on there. And I can go to storage classes, and you see the default when I installed rocks is VPC block. Okay, so now you see also these OpenShift storage classes, and I want to make this file system the default. So one way of doing that is to go in here to the current default. Go in here and do the annotations, and you'll see that this is the default. So I want to copy that. And then I'm going to go into my CephFS, and I'm going to make it the default and set that value to true. Now what you'll note is that now I will have 2 defaults, and that is problematic. So to prevent that, because I don't want my applications to be installed in a single availability zone, I want, like this does, I want it to be a metro availability. So this is called out in the documentation here, customize the default. And if you go change it over here, then it will revert back because it is set here in the CSI config map. So you can do it command line here, or if you'd like to do it through the user interface, then I just go over here to my workloads and config maps, and then all projects, and then just search on that CSI driver, which you see it there. And then you can go down here and adjust it, or I just switch over to the YAML, and then you'll see down here at the bottom, this is storage class default. I want to set that to false, and then I'm going to save that. So then if I return to my storage classes, then that will reset it when it goes. In fact, I could just remove that now, but like I said, if you don't do it in that If you don't do it in the config map, then it will revert back per the docs here. So definitely want to adhere to that. So now let me spin an app up on top of this cluster and show you some high availability features. Okay, so let's now use an app that that is HA or Metro HA aware. So it's going to write a file, as you see here, OpenShift file upload demonstration. It's going to write to a file system that happens to use that OpenShift Data Foundation cluster. So let me go get the app. Here's the copy highlighted text, and then I'm going to go over here to my my OpenShift console, and I'm going to change roles as a developer. I'm going to create a new project, call it Build G Metro HA Demo. And then in here, I'm going to create a new project. You see there's all kinds of application templates to choose from, etc. HA databases, Perl, PHP, .NET, etc. But I specifically want to build one from a Git. Paste that, and it needs the universal base image, version 8 there, and it's going to create it and create a route for me. So now that's creating, and I can see my deployment here, and the build is currently in progress. And here's the service it's building and the route once the pod is up. So let me switch over to the admin role, go into that project, build G, and see what's going on here. It is currently building. You can see view events. It's building. And once it is up, pod is healthy. There we go. So if I go back and go to my route and check that, then you see here's the app. Okay, so this application uses the internal storage unless you create a persistent volume claim that mounts over that. So it will then use my OpenShift Data Foundation file system default storage. So I run this command here, and it does that. It creates the storage, and if I go into my project, into that project, you'll see here's the PVC, and you see it's tied to the correct place. So right now, this is running a single pod. In fact, you can see the pod it's running on 0.5, which is 0.5 right here, Dallas 1. So let's spin up a second copy of that, go into my deployment and make that 2 pods, so I'll have high availability. And so now if I do my OC command to get OC get pods dash, that shows me it's running on 0.5 as well as 128.5, and I know the 128 is the second data center. In fact, you can check over here, 128 is Dallas 3 and the other one is Dallas 1. So I'm going to remove Dallas 1, but before I do that, let me go to the route for that project. Go here, go to the route, go here, and there's the app. Okay, so I can upload a file. Sorry, choose a file first, then I can upload it, legacy, and then upload it. And so I can list the files here. And in fact, if I want to go into it, I can go back over here and let's go into that older pod, which is this one, which I think is on 0.5 right there, right? I'm going to go into it and create a file. Okay, So now I have my terminal and I can do pwd. I want to go to upload it. And there is that file I just uploaded. So I'll do a touch pod1.txt. And then I go back here and see that that is running on this 05. I do a refresh over here, list files, and I see that pod1 txt that I just uploaded. So now let's go remove that 05. I'm going to choose that and I'm going to delete it, and then it'll replace with a new let's just scale it down. So now it's going to delete that server. Okay, so that is going down, and then I go over to my app and go back to the home page and list, and I still see that. And in fact, if I go over here to my pods, back over here to my pods, you see there's a new one that's already spun up on a different IP address because that 05 is gone. I go back here again and go into my deployment, see the other pod, and that was the top one here, and it's gone also. So the 05 is not there. But if I go into this pod, which just happens to be a different pod on a different server, cd upload it, I see it's there. I do touch pod2.txt, right? And I go back over here to my site and I do home and I do list all the apps and I see the new pod. Even though this server is being deleted, in fact the 05 is gone, which is where that was originally running on. I go over here and see my pods. You'll see, in fact, if I just do it over here on the wide list, you'll see that it changed. The 6411 is the new pod that it's been spun up on. And if I go over here, 6411, that's DAL2. So I'm deleting DAL1 and it moved it over to DAL2. And I wrote data to it in Dallas 2, a different data center completely. You see it's deleting. And if I go over to my app, you see I have all the apps. So I have, not only do I have this user interface that's being highly available and redundant, but also the files within that file system under the covers are also redundant. And that's using this OpenShift Data Foundation component of my cluster here. That's out of the box, or something that you can install here pretty easily. So hopefully this has been helpful in showing, you know, the benefits of a highly available sort of metro disaster recovery. Now, best practice will tell you to keep your servers a good 100 miles or so apart, because it is possible that, you know, a flood in Houston takes out all the data centers that are, you know, 10, 15 miles apart. So you do have metro level disaster recovery, but, you know, it's still even better to have a regional disaster recovery protection where you actually spin up a cluster in Washington, D.C. and another one in Dallas, because now you're beyond that range that typical disasters can potentially strike in. But even without that, you know, if you're in Manhattan, then you could have this kind of set up, and then you know, your data centers would be across the city. And so a disaster in one part of the city doesn't take down your application or your data. So RPO of 0 and RTO of 0. Thanks for watching.